Oh, my name is Rick Fitzpatrick, and I'm the Chief Technology Officer for Xtrude2Fill.
And I'm Ron Leach, CEO of Xtrude2Fill. Foundation of our relationship dates back to 1976 when we were roommates at Michigan State University. We lost contact after school this last January, reconnected, and in September of this last year, we formed Xtrude2Fill.
I began my career after college in the plastics industry, working through engineering and management roles. The more immersed I got in the industry, the more I got frustrated with its complexities and costs. I had to ask myself, why do you need such large machines and molds to make relatively small plastic parts? These things were much too complicated. The machines themselves have to generate 20,000 pounds of pressure to be able to melt the plastic and move it into a mold that only needs about 1,000 pounds to fill it. So when you look at a hot glue stick, it's just a piece of plastic. And when you look at a hot glue gun, it allows you to melt and move that plastic with the pressure of your finger. So with that inspiration, among other things, I just formed this vision of there had to be a better way, building it off of heat conduction. And so that's the technology that we want to explain to you today, is what I've been working on for the past 15 years. So ask yourself, what if innovation had stopped in 1956? Because that's actually what's happened with the injection molding industry. The patents that were filed and awarded in 1956 were for the reciprocating extrusion screw that's still in use by all molding machine manufacturers today. This is designed to put that pressure, 20,000 pounds of pressure, onto the plastic to cause a frictional melting. Then that screw is used as a plunger to inject it into the mold. It's all a momentum and power-based system. This leads to larger and larger machines, larger molds, a tremendous amount of facility costs as far as concrete under these machines and support for it, and the amount of electricity that it takes to operate these machines. So we looked at this from a contrarian approach, where if you need 1,000 pounds of pressure on melted plastic in a mold, we start there, and we designed and developed a system that allows us to do that, so that we have a much higher level of efficiency. We have an extruder that has a thinner wall that's designed for heat conduction, so that we can conduct the electrically generated heat directly to the plastic at low pressure in a static condition that allows us to use the screw you see to pump the material into the mold to achieve the pressure with a lot less force overall. So basically all of our machines right now run on single-phase electricity, the same you'd find in any household. And you can use low-cost aluminum tooling because of our control of the pressures that are involved. Lower capital costs, lower overall operating costs, and much lower energy allows us to, with a smaller capital investment, compete with the larger systems, the larger conventional systems, on molded piece part costs. And perhaps more important in the future, we're able to mold mixed recycled plastics and other bio-based materials that conventional machines today cannot mold, because their process will not deal with those materials, and many of the mixed recycleds go to landfills now.
I've spent my entire career in the plastics industry, starting in engineering and operations. The last 15 years, I've been a senior executive in both publicly traded and private equity-owned businesses. Most recently, I was CEO of Tegrant Corporation, a manufacturer of protective packaging, $450 million revenue business. I believe my skill set and Rick's align perfectly for the launch of Xtrude2Fill. So what did I see that compelled me to become the CEO of a two-man startup and put $500,000 of my own capital into the business? I believe we are starting a billion-dollar business. This is a game-changing technology. The conventional system uses frictional energy. Therefore, it has to be a continuous operation. You can't get friction without movement. Rick's invention uses electrically generated heat to melt the material, no movement required. So, like a glue gun, our machine can sit for 10 seconds or 10 minutes, and it's ready to produce a part when you need it on demand. This fundamentally changes our customers' economics. They now can take, and instead of using massive machines and massive molds to put 100,000 parts into inventory, they can go just in time and incorporate our machine into their manufacturing operations. Sometimes technologies are just a continuation of an existing technology, and once in a while you get a disruptive one. Xtrude2Fill is a disruptive technology. It will change the entire economics in the supply chain for injection molding. But as a startup, we've got to focus. First order of priority, get the IP protected. So we submitted 3 provisional patents last December. There will be 3 more patents submitted prior to the end of this year. We've retained 3 trademarks to protect our brand identity. The plastic injection molding market is a $200 billion market. 80% of the parts made in this market are under 20 grams in weight. Our current technology can produce all of that portion of the market. 88,000 machines are sold into the industry every year, new injection molding machines to support this huge market. If we take 1% market share, at our current pricing of about $100,000 a machine, we'll have about $100 million in revenue. So you can see at 10 to 12% penetration of the market, we become a billion-dollar company. Almost any industry uses injection molded parts: consumer goods, automotive, medical devices. So we have to get focused. We have to eat the elephant one bite at a time. Our opportunities are too vast. We will focus 4 machines as our entry, made here in Colorado, a large and small horizontal, a large and small vertical. We'll focus on 3 domestic markets: health and beauty, where products are formulated and filled in the US, medical device that needs short runs and precision molding, and metal injection molding, because metal is one of the most difficult materials to run in the conventional process. We will be a manufacturer of machinery, not a molder, to be clear on our business model. We will focus on large customers because they understand the difficulties with current technology and will recognize the economic value that our machines bring to their business. They also provide technically proficient platforms to launch our technology and give us feedback for further development. My initial capital investment has gone to protect the business from an IP standpoint and put the infrastructure in place. We are now working on setting up a local supply chain of manufacturing companies for the sub-assemblies necessary for our machine assemble business. The economic revenue model in machinery is a beautiful model. The customer pays you 50% down when they place the order. The other 50% when you complete the build. Coupled with over 60% margins in our business, we generate very high free cash flow that will perpetuate the future growth of this business. So can these little machines really make mass production? The answer is yes.
Traditional injection molding machines are all built around a single extruder that's used to melt and move the plastic. So if you go to larger and larger parts or larger molds, multi-cavities, then you just scale up the size of that extruder. But that increases the capital costs, it increases the complexity of the operation, and therefore has a point of diminishing returns. We're able to go on ahead and use multiple extruders that are all controlled by a single microprocessor so that we can fill multiple mold cavities or multiple quadrants of the mold to address the larger parts and larger mold market.
So we ask for your support in fulfilling our vision of building the next billion-dollar manufacturing company here in the state of Colorado.